Can you imagine a future where getting around is super easy, faster embedded with the smartest technology, and you don't even have to drive? Well, it might not have to be cars all the time. In fact, the future of transportation doesn't hinge on the cars, no matter how faster or technologically advanced they may seem. But there are things that will. Meet the Hyperloop, a futuristic train that could run faster than the speed of sound. You might think it's a wild idea, but tons of smart people from all over the world, including some iconic entrepreneurs and investors, are working hard to make their vision into a reality. So, are we going to stick with the same humdrum ways of transporting around, or wait for a tentative future of humdinger of mobility? Here is Los Angeles, the city where dreams come alive. It's the place where a futuristic way to travel faster is being wrought. The Hyperloop, a train that zips through a special vacuum tube. And it all started with the vision of Elon Musk, a billionaire who turned up the trumps in internet ventures, electric cars, and personal space travel rockets, some of the fields which were never explored by one individual at the same time. However, Elon Musk could be a Pied Piper for that, but wasn't solely focusing on constructing the Hyperloop himself. Instead, he's organized a global competition for students regarding the new mode of transportation. He said,
So what this is really intended to do is to encourage innovation in transport technology, to get people excited about new forms of transport, things that may be completely different from what we see today, but to really just get people to innovate and think about doing things in a way that's not just a repeat of the past, but to explore the boundaries of physics and see what is really, really possible. And I think we'll find that it's way more incredible than we ever realized. That's really the overarching purpose of this Hyperloop competition.
There was a team from Munich who were highly firmed to partake in a competition, building the fastest futuristic prototype of the Hyperloop. And it's not just them. They were challenged by some of the most highly enthusiasts who were keen to make the first, yet the best prototype ever with vigor and steadfast mindset. The big question was, which team would build the best Hyperloop prototype? More than 400 teams of students submitted their ideas, and out of all those, the best 27 got the chance to build their prototypes. They all gathered in Los Angeles for the first ever face-off. One team even came all the way from Tokyo. Their idea? Well, they were all about shaking up how we travel. See, we've been relying on cars, boats and planes for like forever, right? But they thought it was time for something new, a super speedy way to get around the world. There was an interesting team, the youngest of the bunch. All of them were still in school. Those 16-year-olds from Texas teamed up with their teacher to build their vehicle. Young people started not caring as much about having their own car in the past, which used to be a symbol of freedom and independence. But as more people have started to make more money, and as have the population, cars are getting increasing demand from that rising population. This means our roads are getting packed and there's always construction and traffic jams that are putting more strain on the ongoing busy roads. The concept of the Hyperloop isn't exactly brand new. It's actually originated from the idea from the pneumatic mail tube. Back in the day, especially in places like New York, they used these large tubes to rapidly send letters across the city and even within buildings. The letters were sealed in containers and propelled through the tubes by air pressure. Those can reach speeds of up to 40 kilometers per hour. Surprisingly, a similar system is still in use today. Now, the Hyperloop is more or less inspired by that technology, but to know more about Hyperloop, you need to know how the system works for canisters, as that's the quintessential way of making something faster. When the canister is sent through a pipe, it needs to fit so well no air can pass in and around that. When the air is sucked out in front of the canisters, it creates a suction of air at the back of that, but at the front, there becomes a scarcity of air leading to shot out of that canister. Hyperloops work with the same theory, with more complexity. It's essentially a high-speed train that travels through a tube where most of the air has been sucked out. This creates a nearly airless environment, which allows the capsule to float through with minimal resistance. To ensure passengers can breathe comfortably, they travel in a cabin with normal air pressure, similar to an airplane. This low air resistance is what makes the Hyperloop so fast. Can you guess the speed? It is expected to reach around 1,200 kilometers per hour. With such velocity, it's theoretically possible to travel between Paris and Berlin in just about an hour. That's the vision, at least. But the entrepreneur, Dirk Ahlborn, wants to show that it can also work in real life.
We have the chance to develop a means of transport the way it should be done in 2017. Of course, we need to be able to use various pieces of technology. When I consider just how much time I spend in traffic and in our car or trains, I think just how many better options there are.
A few years back, Ahlborn started a company in Los Angeles. It was just one of many startups that wanted to bring the Hyperloop into reality by building a team of engineers who solely understand and hence apply the theory. At least the advancement was noticeable when the idea turned into some sort of improvement, more than just an idea. But they had to look for investors. So, they gave potential investors a crash course on how the Hyperloop would work using abstract models. Above all, magnetism is what will drive this entire concept. Magnets play a huge role in two key parts of the Hyperloop. First, they help the capsule float, and second, they push it forward, both to reduce the friction and enhance speed by avoiding resistance. These magnets are attached below the Hyperloop capsule. As they move along the bottom of the tube, they create another magnetic field with both north and south poles. As we know from school that similar poles repel each other, that leads the capsule to float. There's also this aluminum fin that helps it move. This fin glides along a track made of magnetic coils. These coils can be turned on with electricity, which then creates a magnetic field in the aluminum fin. The magnets in the track push the capsule forward, making it move. It's pretty complex tech that still has a lot of questions to answer. At Ahlborn's company, they believe in the power of teamwork. Even though the main office is in one place, the employees are scattered all over the world and they stay in touch through the internet.
We gathered a small team together and said anyone who wants to be a part of this and is ready to give at least 10 hours per week in exchange for a share in the company in the form of company stock options, or better said, the shares or share options, should get in touch. Then we had around 200 applications. Out of those, we selected just 100 engineers and worked with them on a feasibility report.
The students from Munich set up a temporary workshop in Los Angeles to put all the parts of their capsule. Even though they've brought it all the way to the USA, they still need to pass a test to make it to the way. Whether they will be allowed to participate in the direct run of this or not depends on how well their system is developed. During construction, they realize some crucial parts are missing. These parts got held up at customs, and without them, they have almost no chance of getting access to the tube. But they still had another week to try to sort things out. For the students, this project mattered because they could foresee that they would revolutionize the future way of transport, which would benefit not just them, but also their forthcoming generations, and so on.
It's such an important concept of travel. We dream of making a quick trip to Australia one evening for dinner and coming back again. We dream of being able to change places quickly, to be able to shrink the world down, so to speak. That's something that has been just a dream until now.
Now, this concept of hyperloops wasn't the first time people heard of it. Beyond trains, it was already a proposed subject back in 1867. Inventor Eli Beach was the first to dream about this project, only on a car, in 1867. He wanted to create an underground commuter car in New York that could smoothly whisk past a tube, powered by air pressure. But city authorities were reluctant to simply be carried away with Eli's idea. It wanted to continue this system only for the mail packages, but not for humans. Despite such unwillingness by the city, Beach encouraged his team to continue developing the train for people to prove the viability of his planning. But the city remained steadfast to its decision and chose the traditional railways over Beach's innovative concept, and wanted to invest further in both underground and above ground, but still not to that concept. For more than a century, trains have been the backbone of Western transportation. with complex infrastructure. Building railway systems involves laying tracks, setting up signalling systems, and building stations. And everything needs a huge long-term investment. In fact, today's cities have grown around railway lines and stations, which makes them vital parts of urban life. Mobility isn't just something we take for granted, it's a hard-won freedom that brings us immense joy. Before modern transportation emerged, people were often confined to their local areas. Horses were the fastest mode of travel at the beginning of the 19th century. As they are animals, they require frequent breaks and meals, meaning you need to put a halt to your journey after every 20 minutes or change the horses that would be ready for you at your rendezvous point. That's why, during the Roman era, post offices were thoughtfully constructed in well-traveled routes. They offered fresh horses for weary travelers. However, keeping the horses cost an arm and a leg. They consumed around 6 tons of food annually. People needed huge land and labor to grow all that food. Oats were the main food of the horse, which was a bit pricey at that time. In 1815, the explosion of the Tambora volcano in Indonesia sent sulfurous particles into the atmosphere, which created a global veil that blocked sunlight. The volcano's outburst created a global haze that blocked sunlight. The lack of sunlight caused a year without summer, which led to crop failures across Europe, especially oats. This made oat prices hike that inflicted misery even to the wealthy people who wanted alternatives to horses for travel, let alone the underprivileged. Historians weren't sure if the volcano directly inspired inventors, but a guy named Carl von Drais from Mannheim invented something cool called the Draisine. It was like a walking machine and became really popular. As prosperity increased, more people could afford to travel, meaning people could afford their own cars and drive it independently without relying on any public transport. Hence, the car managed to gain all the attention it deserved, even surpassed the popularity of the railways. However, congested roads, environmental damage, and expensive fuel put a challenging path forth to these cars. Despite this, manufacturers began to reconsider their approach. In the future, mobility, digitalization and marketing may all work together, and cars could potentially hold all the technology which passengers of today might not think about at those times. And astonishingly, it's happening these days, isn't it?
That's the problem in traffic. It's not usually the technology. The technology is easily available. The problem is people themselves, and the question is how people use technology. Who reads 500 pages of their car manual nowadays so that they can operate each inbuilt system?
Now, one of the major issues of driving autonomous cars is that the passengers often forget that they are in the car that was once driven with both hands on the steering wheel. It's true, the autonomous vehicles have given us a slight relief of holding off our hands for a bit to scratch our elbows. But it doesn't justify under any circumstances that you can get your hands off the steering wheel for a long time, and that too, your eyes are away from the road to simply a person next to you. Another curse is vlogging, making videos of every scene that you experience while driving your way to the countryside or somewhere you wish to go. Recording each scene means you need to constantly move your eyes off the street, making you more prone to car crashes. Unfortunately, many people don't take this responsibility seriously and share videos of themselves engaging in other activities while their car is in motion. Therefore, the drivers must be prepared to take control of the steering wheel at any moment. Currently, the autopilot function of these cars is only capable of avoiding collisions in certain scenarios, which is insufficient for handling complex traffic situations. In May 2016, the autopilot feature of a Tesla car was involved in a gruesome accident that caused the death of the 40-year-old passenger, Joshua Brown. Brown's car collided with a truck without braking, even though the truck was visible for several seconds before the crash. Typically, the autopilot system scans the lane directly in front of the car and applies brakes if it detects any obstacles. However, in this case, the truck approached from the side, and the Tesla's sensors failed to recognize it due to the truck's large wheelbase, which temporarily cleared the lane according to the car's scanning system.
The sensors do register an obstacle, but because the lane appears to be free, it is interrupted as an overhead sign. The sensor technology in self-driving cars today is mainly intended for motorway driving. It's not yet ready to give a good overview of complex intersections. We could even say that it may never be ready for that. For that, we need a far greater capacity for detection. We'd need to know far more about the crossing traffic that is not yet in sight. But it's, unfortunately, the case that people nowadays jump to the conclusion that the cars can do everything, which the Tesla accident showed us.
Meanwhile, in Los Angeles, the students from Munich reached the competition site. Lucas and his teammate Thomas spent time comparing their design with those of their competitors. Finally, their last parts were released from customs, which marked their readiness for the initial test run. Success in this trial could pave the way for the team to enter the tube. One of the team members said, "One of the few teams utilizing a compressor like this had one goal in mind: remove residual air from the tube. The tube holds a partial vacuum with an atmospheric pressure of 100. Without this step, air friction could slow down the pod. By sucking the air out, the vehicle can travel swiftly through the tube without feeling any air resistance." Then the next step involved attaching magnets onto the prototype, or pod for short. These magnets facilitate the pod's floating ability, and they are affixed to the underside. Once the pod accelerates to approximately 180 km per hour along the track, the magnets generate sufficient buoyancy to elevate the pod. Unfortunately, the test pipe wouldn't suffice for a pod to accelerate the speed it was meant to build for. What Elon Musk desired for was only applicable for a bigger pipe through which the desired speed could have been reached and maintained. But this very tiny little pipe is not going to even ignite the push it wanted. Hence, it needed a support vehicle called a pusher. This vehicle did nothing but only boosted a kick that allowed it to be lifted and floated. This feature was super helpful, especially in places with limited infrastructure. The Hyperloop would not be on the rage for its speed, but for its travel distance shortage too. For say, it takes 6 hours to drive between San Francisco and Los Angeles, where the road is straight by the side of desert. This makes flying the only option for such distance. But with the Hyperloop, that same trip could be done in just 36 minutes. Plus, the Hyperloop could use energy sustainably by getting power from solar cells on the tube's roof. In 1985, Transrapid, a type of magnetic levitation train, was given a short train, and it marked a major event in Amsland in Lower Saxony. This train, unlike any trains, didn't rely on an air-free tube, but instead, it had to harness the magnets to move forward. It reached an impressive speed of 412 km per hour, faster than our current high-speed trains. From the outset, Transrapid received widespread condemnation from all across the country, whereby people were skeptical about the large investment comes with its own set of personalized infrastructure. While some viewed it as a wholesome moment to pride, a few German politicians were already off the feet to bring the limelight into the matter of its sheer costing. On September 22, 2006, a routine test run turned tragic when the Transrapid collided with a workshop van that had been mistakenly derailed from its track. The devastating crash claimed the lives of 23 individuals and left 10 others injured. Today, the location where the accident occurred serves as a touching reminder of the tragedy. In the aftermath of this heartbreaking event, there has been considerable hesitance in Germany to continue investing in the Transrapid project, despite its proven success in Shanghai since 2002. Safety protocols for the Hyperloop are still in the early phases of development. At the Los Angeles competition, students are focusing on integrating the highest possible safety standards into their models. However, their prototypes are not yet equipped to transport passengers safely. Presently, the pods are only outfitted with the necessary technology for traversing through the tube. The students have yet to address the crucial aspect of the pressurized cabin. If the cabin fails, passengers in the vacuum would be at great risk. One of the contestants from Boston said,
"It's kind of like the airplane claustrophobia and depressurization problem amplified, because you have no windows, and if it depressurizes, you're definitely going to die. So we need ways to mitigate those problems. I think having a comfortable cabin that is spacious and stuff can help deal with claustrophobia. And there definitely need to be safety systems to deal with depressurization and emergency evacuation, so that those are problems that need to be solved.
One more problem was how fast it would run. The speed was predicted to be up to 1,200 kilometers per hour. Could people handle that? Nowadays, fighter jet pilots are used to going at 3,000 kilometers per hour. They have special training and wear suits for protection. But the real danger wasn't just the speed itself, it was the speeding up and slowing down. That was tough on the body, especially during takeoff and landing. Unlike regular travel where you go up and down, the Hyperloop keeps going at a steady speed. It felt a bit like being on an airplane for passengers, but it would definitely take some getting used to, especially because of the vacuum. Well, if we look into the transportation systems of international trade, those ships are unbelievably slow compared to the Hyperloop. Large container ships typically travel at just 23 knots, which is approximately 42 kilometers per hour. Right now, the ways we move goods around are feeling a lot of pressure, and predictions suggest they could increase by 38% in the future. A ship can carry as many as 20,000 containers in one voyage, while a Hyperloop can only carry one capsule at a time. To deal with this difference, experts are looking into ways to make truck transportation on roads more efficient through something called truck platooning. This means several trucks driving in a line on the highway, connected by Wi-Fi, to respond together. The first truck leads the others, which save fuel by traveling in its slipstream. This concept could theoretically be applied to cars as well. In platooning, vehicles are kept a short distance among them, and they move together with the same pace. It reduces the traffic congestion commonly visible in the urban area or motorway. If a driver wants to join the convoy, the intelligent system embedded in the lead vehicle takes over the control of that car and automatically controls it. Like this way, other cars joining the convoy are all led back behind the lead car. However, where the concept is same for both train and car platooning, there is a difference in that too. Unlike trains, where the entire system is controlled centrally, in platooning, each vehicle in the convoy is aware of how the system operates and contributes to its functioning. For platooning to work really well, it's important for many cars to be connected and able to talk to each other. But right now, car manufacturers haven't agreed on a common way for their cars to communicate and work together. This makes it hard for platooning to reach its full potential. At the German Aerospace Center in Braunschweig, scientists are laying the technical groundwork for this innovation. They are developing a car equipped to function as a data center, similar to a smartphone on wheels. They are utilizing technologies like GSM, UMTS, and GPS to facilitate signal transmission. The researchers are developing a car that's capable of independent communication with its surroundings. It brings a potential breakthrough for autonomous yet safe driving. These cars are not only designed to interact with other vehicles, but also with the overall environment. However, achieving this needs standardized communication across all elements of road traffic. In central Braunschweig, they've started using smart traffic lights that tell cars how long the green light will last and when it's going to turn red. Tests have shown good results so far. Looking ahead, cars might be able to keep track of where other vehicles stop and even spot pedestrians as the world becomes more connected. By collecting and studying data all the time, cars want to make roads safer. As morning draws into the dawn in Los Angeles, it's competition day for the students from Munich Technical University, and things are getting real. Their capsule is all set for the test run through the 1.5 kilometer long test pipe. The goal? To reach speeds of up to 350 kilometers per hour. But what about their competition? Well, most of the other teams that came here didn't make the cut. They either didn't have the right technical skills or simply weren't ready on time. Besides the Munich team, only 2 other teams have qualified for the final round. If the pushing vehicle doesn't speed up enough, the pod won't reach the speed required to float. The magnets can only lift the pod once it reaches 180 kilometers per hour. The Dutch students went into the tube first with a fancy design, but they got stuck halfway because their pushing vehicle had problems. Then, it was MIT's turn. People thought they'd clinched the competition for sure, but even they couldn't make it to the end. Now it was Munich's chance. Even though they were bummed about their first try, the team was ready to give it their all this time. Their success relied on how strong the push was and how much friction there was in the tube. The prototype got off to a good start and was the only one to finish the course, even though it didn't go as fast as sound. So, Germany claimed the prize for the fastest pod. But what about the Hyperloop's future in Europe? Plans are underway to establish a research centre, which indicates Europe's commitment to future Hyperloop development.
Well, I think that Europe is particularly interesting because we have shorter distances here. The system in general is perfect for distances within around 40 minutes to an hour. I think that's especially interesting at a time in which Europe seems to be falling apart. It's a way we can think of to bring people together more.
Auburn has signed a contract with the city of Toulouse to establish his research centre there, despite his company not having a working prototype yet. Toulouse is known for being really good with technology. It's part of a program called French Tech that helps new tech companies grow. It's uncertain if France is planning any Hyperloop networks. For a city like Paris to benefit, the Hyperloop station must be easily accessible. But many cities already have stations in the middle, and the roads to the edges are really busy and crowded.
If we just build something, let's say it takes you from Los Angeles to San Francisco within 36 minutes, or from Paris to Berlin in a little over an hour, it still takes an hour and a half to get to the station. You really haven't changed anything in that.
For the Hyperloop to work well, other transportation methods need to be improved too, and all the different ways of getting around need to work together smoothly. The capsule designed by the German students is now on display. It's meant to inspire the next group of students who will work on the project and come up with new designs for the competition in Los Angeles. The second pod differs from the first one mainly in weight. They stripped away anything that slowed down acceleration, making the second pod much lighter. In the second competition, the goal is simply to go as fast as possible inside the tube. During their second attempt, the students are determined to achieve the needed speed for liftoff without relying on the pushing vehicle, because it caused issues in the previous competition. Their solution involves incorporating a lightweight electric motor as an alternative driving force. This motor needs to be exceptionally light to ensure the Hyperloop can achieve the necessary speed to float. To meet this requirement, the entire vehicle must weigh no more than 80 kilograms. Consequently, the students are actively reducing the weight of the capsule through systematic modifications. Existing rail networks, like the TGV in France and the ICE in Germany, are facing capacity constraints. While the TGV has dedicated tracks, ICE trains share their routes with regional and freight trains. When there are delays in one part of the system, it can cause problems in other areas too. Things like construction, areas where the flow slows down, and organising schedules can make these issues even worse. Even though a lot of money is being spent to make the rail system bigger, it's still cheaper than coming up with a whole new way to get around, which makes things difficult. In Los Angeles, traffic congestion is a major issue. The city's 18 million residents rely on cars to get around every day. But it wasn't always like this. Back in the 1950s, trams were popular in Los Angeles. They were affordable and provided good connections, so people didn't feel the need to buy expensive cars. However, by 1961, the trams were all gone. A company bought them up, but decided to shut them down instead of running them. This decision was backed by car companies, oil producers, and tire manufacturers who wanted people to buy more cars. As a result, Los Angeles became known as a city dominated by cars. Every city faces its own set of challenges, influenced by its residents. However, there are some shared factors to think about, like public transportation and how people get around, that will shape the next 50 years. It's doubtful that we'll entirely give up cars and depend only on public transport. There's no one-size-fits-all solution for cities in the future.